Section 4.8 is on relations and functions. So we're going to talk about what is a function. And I like this picture down here below. It's what I like to call function machine. And you'll see that this function machine has a spot where you get to have an arrow going in. That's going to be an input. And then it's got the little machine part. That's the box. And then it's got that little arrow coming out. That's the output. So a function is going to be something that where we can put something in it, an input, and we can get something out of it, an output. A relation is a set of ordered pairs, and a function is a relation where you have a one-to-one relationship between the inputs and outputs. So in this example right here, you'll see that the top one that says it's a function has an input of 1 twice, and that input of 1 has an output of 7 each time. That's a one-to-one relationship between inputs and outputs because an input 1 has 1 output. Down below where it says not a function, you'll notice that when you have an input of 1, you get an output of 6, and later when you put an input of 1, you get an output of 8. That is not a one-to-one relationship. I would call that a 1-to-2 relationship. You had 1 input and 2 outputs. So you can look at a table and figure out whether the relation is a function by checking to see if there's 1 input for 1 output. Another way to do the same thing is something that we like to call the vertical line test. It's a real visual way of deciding whether something is a function or not a function. And on the left, if you took that red line and you passed it from negative infinity all the way through positive infinity, that vertical line would only touch the graph in 1 point at a time. But in the right equation, you can see that where the vertical line sits now, at about positive 5, it touches the relation in 3 different spots. So each input has more than 1 output. The input of 5 for x has an output of about 7, -4, and about -8. So this would not be a function. Function notation, I like to say that when you have your function is y equals mx plus b, that all you have to do is replace the y with f of x. And that's how it's read. It's not f times x, it's f of x. So when you're evaluating this function f of x equals 7 minus 3x, it's just like that was a y. And so we're going to plug in 4 for the x. So again, on the left, it doesn't say that we're going to multiply f times 4. All that is saying is that we're going to evaluate the function when you plug a 4 in. And so you have 7 times -12, or 7 plus a -12, and that's -5. So f of 4 is -5. And as an ordered pair solution, that would be 4 comma -5. We don't have to just use the notation f of x. You can use any letter. So g of x. Here, this would be the g function. And in this problem, they're saying when g is -2, or what is our function value going to be when we plug in a -2 in for the x? So you plug in the -2 in for the x, and you can see that you're going to get about -17. So again, that would be equivalent to an ordered pair solution of -2 comma -17.